In this video, we're going to talk about how to use the Pandas JSON normalize function and go in depth on the arguments that you can pass into this function. Within the video description, I've included a link to the GitHub repository that has the Jupyter notebook that I'm going to be kind of walking through today. If you want to kind of follow along, you're welcome to go to that, download it, and you can go ahead and just follow along with me here. We're going to go ahead and start by importing pandas as PD. And then we're going to also import JSON. Now JSON is a library that comes pre-installed with Python, so you don't need to download it or install the package or anything like that. It should just be preloaded. And basically it will allow us to work with these JSON files a little bit, get it ready so that we can actually use the JSON normalize function. So go ahead and import those. Okay, so first thing that we're going to want to do is actually open up the JSON files, and we're going to do this in kind of two steps. So the first step that we're going to take is to open it up in a text format. So initially when we're reading this into Python, we're going to just go ahead and open it up in a text file format, and then we're going to actually load it as a dictionary object within Python. So let's go ahead and do that. I'm going to type f is equal to open. I'm going to do some auto-completing here, make things a little bit easier. So we're going to use this first, or excuse me, the bottom one, not the flat one at the top. We'll go over that one later. And then what you're going to want to do is, since we're opening it, we're going to go ahead and put read as the argument there. Okay, so now I'm going to define the file, and this is actually going to be our Python dictionary that we're going to convert here. We're going to do that using the JSON library, so type JSON loads, and then type f.read. So essentially it's going to read the lines of the text file. And then, just so we can get an idea of what's going on here, we're going to type out print, and then type, and file. Okay, let's go ahead and run that and see what we get. Okay, so we just wanted to see what the type was. You can see now that it is a dictionary, right? So we're no longer working with a text file at this point, or even a JSON string file. It's actually a dictionary within Python that has key value pairs. So that's going to be very important to working with JSON files. We'll go into that in a little bit more detail coming up. If you want to actually see what this looks like, you can go ahead and type file right after the print statement there, and it should pop up with this JSON format here. And again, this is a dictionary, so it's not technically JSON. It's a key value pair, which is how JSON's structured, but it is now a Python dictionary. All right, so I just commented that out so that we don't have to look at all that text. Let's go ahead now and talk about navigating these JSON files. When I say navigating JSON files, what I really mean is navigating the dictionary within Python. One thing to note is you can have key value pairs where the values themselves actually have more key value pairs. And so you can have sort of a hierarchical structure to your dictionaries that allow you to step further and further in and go deeper and deeper on different levels within your files. We're going to just go ahead and navigate through a few different levels just so you can kind of get the idea of how to navigate through some of these, and then we'll actually go into utilizing the JSON normalize function, and we'll walk through all of the arguments that are in that function itself. Alrighty, so in order to navigate through some of these levels, we're going to type file.keys, and this will basically just give us that first level. So on the first level we have meta and data as our keys. So two main keys. You might have a different structure when you're working with a different JSON file. Just depends on how they're set up. In this case, what we have is the data key contains all of the data set information, and then the metadata just contains all of the, well, just that, right? It's pretty self-explanatory, the metadata about the data set. So let's go ahead now, we're going to take a step further into the meta tag, and we can do that by typing file, and then we're going to step into it here. We're going to say meta, we want to look at the meta key, and then we're going to type key here, or keys I should say, And now we have this additional key here that says view. So I'm not quite sure why they structured it this way. They could have probably just skipped this extra level for this data set, but again, we can take a further step again into this view key and see even more keys. So let's go ahead and do that here. We're going to say File. Once again, type Meta. We're going to do it again over here. Brackets, we're going to type View. And then once again, we're going to use that keys function. Okay. So now we are here in the third level here. We've got all of our metadata. So this basically gives us all sorts of different information about the data set. You know, who owns it, when it was created, when it was last updated, things like that that maybe might be useful to the user. And we are going to use something later on to help make the data set look a little bit cleaner when we actually use the JSON normalize function. But we'll go into that a little bit later. If you wanted to kind of see what it looks like to step into some of these values and actually get a value back, let's go ahead and do that here and just kind of take an example. We're going to copy this thing that we used up here, and now we're just going to type, let's say we want to look at the name. So let's go ahead and just run that. And as you can see, we get the name of the data set, which is 100-year storm plus 24-inch sea level rise, kind of a longer name there. But you kind of get the point where you can kind of step into these keys and then get their values just by passing in whatever the path is to get there. And again, we'll use this when we actually use the JSON normalize function as well. Okay, we are now ready to use the JSON normalize function. There is a little bit of backstory that we had to go through to kind of learn how to navigate these JSON files. Now let's go ahead and just dive right in and start using the JSON normalize function. So I'm going to type data and set that equal to PD. That's pandas that we're referring to. We're going to type JSON underscore normalize, and I'm just going to tab autocomplete here just to make it easier. And now I'm just going to type the file itself. So what we're doing here essentially is just getting all of the default arguments. We're not going to pass anything other than the actual dictionary that's already preloaded. So let's go ahead and see what that spits back. So we get this kind of interesting data frame, and you can see that we get the paths that take us to some of these different values that we were kind of showing before. Notice that the meta.view.name is exactly what we did up here to get that title of the data set. Now, like I talked about before, this data is what we actually want to use within the JSON normalize function to actually get the data set and put it in a nice data frame. We're going to go ahead and do that next, and the way we do that is by passing in the record path argument. Now what I'm going to do to make this a little bit easier is I'm just going to go ahead and copy and paste from the cell above, and then we're just going to go ahead and pass in the actual path that we want to use. So just starting off real simple, I'm going to type record underscore path, and I'm going to set that equal to data. Now with record path, you can either pass in a single string, which is basically a key within the dictionary, or you can do a list of strings that are the path that will take you to what you want to kind of use as a data frame. Alrighty, so we get a data frame that is, for the most part, pretty nice. You can notice there is some column headers that are missing. We do want to kind of go back and get those, and we actually have those within the metadata, and so we'll kind of dive into that. Alright, so what we're going to have to do is generate a column list based off the metadata. Now up here, if we scroll up a little bit, you can see we've got this columns key within the metadata level. So let's go ahead and dive into that, and we'll walk through an example of how to get there using, again, the record path from before. And I'm actually going to just copy and paste this from my notes just because it's a little bit easier. You can see we've got a list of keys. Alright, so we get back this nice data frame, and you can kind of explore it a little bit if you want to learn more about it. But essentially what we're going to do is we're going to use this name column to populate our headers up here in this data frame. Now to do that, we're going to have to create a dictionary. And so what we're going to do here is we're going to type call list here. That's COL list that I'm typing out. and then I'm going to pull from the data frame we just created, and I'm going to grab the name column. Now, in order to make this an actual dictionary that we'll be able to pass in and use, we're going to go ahead and type to dict, D-I-C-T, and then I'm just going to go ahead and display what this looks like just so you guys can all see. Alright, so we get a dictionary with the row number and the corresponding name with that row. And this is going to work perfectly when we go to actually rename our columns up here, our column headers. And so let's go ahead and do that next. Alright, so I'm going to type data.rename. And then I'm going to type columns. We're going to take the columns within the data frame that we created up here. And again, we're just going to pass in these column headers. So to do that, we're going to type call list. Now, one interesting thing you do have to do is type in place and set that equal to true. If you don't do that, it won't be permanent. So go ahead and make sure you pass in that argument, and then let's go ahead and see what the data frame now looks like with the column headers. Okay, so now we have more information. We can kind of understand better what these columns are actually doing. Let's go ahead and head over to the next argument. Alright, so the next argument within the JSON normalize function is the meta argument. Now this is set to none by default, but you can pass in metadata that will basically append another column that has additional information about the data set. Alright, I'm going to go ahead and just copy and paste from the notes here. And so the only argument that we're adding here is the meta argument. And what I'm going to go ahead and do now is just pass in the meta key, and we're going to kind of see what that does as we pass it in here. Alright, so again, we don't have the column headers because we read this in differently, but we do have this new meta column here that has basically all of the key value pairs within a dictionary. Alright, so our next argument is going to be called meta prefix. Now, this is used in tandem with the meta argument that we just discussed, but it's going to add on a little bit of extra meaning when you want to go ahead and add these columns in. Alright, so this next argument is called meta prefix. Up to this point, we have used a JSON file where the two main keys were on the first level. That was the data and meta keys that we talked about earlier. Rather than having main keys like data and meta, you may have multiple keys on the first level, creating what is known as a flatter JSON structure. Assuming you want to include metadata, you can use the meta prefix argument to help you organize these additional columns. We're going to go ahead and use a modified version of the sea-level rise.json file, and basically all I did was I removed the meta and view keys so that all the meta keys are basically on the same level as the data key. But let's go ahead and once again import pandas as PD and import JSON. Okay, now I'm going to go ahead and open that new file. So again, we need to walk through how to do that. Just F2, and then we're going to type open. And then I'm going to actually use this sea-level rise flat.json file. And once again, we need to open it in read mode. I'm going to type file2 just to keep them separate. Then we're going to use the JSON.loads argument again. Type F2 read. All right, and let's go ahead and take a look at the actual file itself. Okay, so you can see right away it's a little bit different than how it was previously. We no longer have this meta tag at the very front like we did in the last file, and it's a little bit more flat. All right, I'm going to uncomment that out, run that again just so that we can get it out of the way here. All right, let's go ahead and navigate this new file. All right, so on the first level you can see there are already way more keys, and again, we still have our data key here, but now all of the metadata is included within that same level. Again, this is more of a flatter structured JSON file. All right, so again, we're going over the meta prefix argument here. Let's go ahead and actually put it into action. So for this one, I'm going to type data, set it equal to pd.json, and then type normalize, do file2, and we're going to keep the record path set to data. That actually needs to be a string. And now we have the meta. So in this case, when you have a flatter JSON file, you can take some of these different keys, as long as they're on the same level, and make those your metadata. So I'm going to type name, category, and metadata. All right, now we're going to type meta prefix. This essentially allows you to take the flatter JSON files and organize them a little bit when you actually convert it to a Pandas data frame. So in this case, I'm just going to type meta dot, and that'll be the prefix for all of these different meta tags or keys here. Okay, when I run that, now I actually get the values within these different tags because it's a flatter file. It is a little bit more helpful this way, and you can see we've got that prefix of meta on all of these different keys right here. Okay, similar to the meta prefix, you can also have a record prefix. So the record path data, we can also add a prefix there, and that's pretty straightforward as well. I'm going to go ahead and copy and paste from above. We're going to keep most of it the same, but we're going to type record prefix, and then I'm going to type data dot as the prefix there. Go ahead and see what that output gives us. Okay, so pretty straightforward. You can have a meta prefix and a record prefix if you want to kind of organize them, make it easier to understand where they're coming from. All right, we're going to go over the errors argument next. Now the default behavior for this argument is to raise the error and exit the execution of the code. So basically the code will error out, it won't complete, and you won't get a data frame. Now this only happens when meta keys do not exist. So when you're adding in these meta keys, sometimes there might be some missing values within those keys, and so it makes it hard to actually finish the data frame. So you can overwrite that by passing in ignore instead of using the default. Let's go ahead and copy and paste the code from above again. Okay, we're going to type error ignore. Now if I was to run this without making any changes, nothing would really happen, nothing would change. Let's go ahead and instead of using this meta tag, let's use an example. So we'll say non-existent. Should have picked an easier word there. All right, so this tag does not exist up here. So let's, again, looking at these dictionary keys, there is no key that is called non-existent. All right, so when I run that, what happened was it still created the data frame, but it replaced all of the missing values with a NumPy NaN value. Now let's see what would have happened if we didn't have this errors argument. All right, so you can see that it errored out here, and there is a really helpful comment below as to why it errored out. It tells you exactly which key was the problem, and then it also tells you how to fix it by saying, hey, pass in the errors and set it equal to ignore. So super helpful and nifty on Pandas' part to kind of explain that and help you troubleshoot really quickly. All right, we're going to now go over the SEP argument. So we're going to go back to the original file that we started with, and we're going to demonstrate how the SEP argument is supposed to work. SEP allows you to change the path separator. While this may look similar to prefixes, there is a fundamental difference. Prefixes overwrite the JSON-defined paths and are used for organizing flatter JSON files. Separators, which is what we're going to talk about now, are JSON-defined paths used to show where the data is coming from within the hierarchical JSON files. So key difference there, important to note that they are not the same as prefixes. Let's go ahead now and go through an example of how to use it. All right, so copying and pasting from above, we're just going to run this file again. And you can see right here, just like we talked about, there is a path that leads to this ID and eventually this value. Now, what we're talking about when we're talking about the separator is we're talking about this little period right here. And that is the default, which if you want to, you can override. So let's go ahead now and again, let's copy and paste. This time let's pass in the SEP argument. And I'm going to do something that stands out. So let's just do 3 of those. And you can see it just replaces that period. If for some reason you don't like the period, you don't like how it looks, you want to make it more defined, you can pass in whatever string you want and it will put that between your path keys. Alrighty, we've come to our final argument, which is the max level. By default, JSON normalize goes through all levels of the JSON file. And again, when I say JSON file, what I really mean is the Python dictionary. By default, since it goes through all of the levels, you obviously get this data frame right here that has the entire walk to all of your different variables. But you can override that with the max level. Now, we've talked about levels before, and one of the nice things about JSON normalize is it allows you to specify how far you'd like to go. So I'm going to go ahead and copy and paste from above, and I'm just going to get rid of the separator argument here. Type max level. And for this first one, we're just going to start with the first level. So I'm going to type in 0. And you can see we get those first 2 keys that we had previously. Now, if you want to take a look at what the second file looks like, you can go ahead and run that with file 2. And similar idea where it's just looking at that first level. So these files are very fundamentally different. And they're going to have obviously different levels. This file 2 is a flatter structure. The first file that we had is more of a hierarchical structure. So going back to that, let's go ahead and take another step into this and just explore some of these different levels. So what I'm going to do is I'm going to skip the second level and go straight to the third by typing 2. And when I run that, it's going to go ahead and give me some more columns here. So now we're stepping in further and getting more of these columns. If I want to do it one more time, I'm going to go ahead and just copy and paste again and step into the 4th level here. Whoops, type the right number there. Okay, so as you get further and further in, you're going to have more of these columns. In the end, what JSON normalize is trying to do is flatten the JSON file for you so that you can kind of read it a little bit easier. All right, so that's it for this video. If you liked it, subscribe to our channel, drop us a like. If you have questions, please drop them in the chat below. If you missed it, we do have this Jupyter notebook hosted on a GitHub repository that you can navigate to and kind of walk through all of these examples and really just dive into this JSON normalize function. Okay, thanks for watching, and we'll see you at the next one.